Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 8. This is Section 11.1, Problem number 8. It says, consider the function x squared minus 7x plus 10 over x squared minus 4, and then find the limit as x approaches three different input values. And the first one, part A, is find the limit of x squared minus 7x plus 10 over x squared minus 4 as x approaches 0. So I want to see if I could just put in a 0 for x and get some type of sensible answer if the function is defined at 0. And it turns out that it is. If I put in a 0, I do not zero out the denominator. So to find the limit as x approaches 0, I can make the x squared in the numerator become 0 squared. The 7x in the numerator, which is really 7 times x, becomes 7 times 0. There's a plus 10 at the end. And now in the denominator, I'm going to put in a 0 for x. And I have x squared plus x squared minus 4, so that becomes 0 squared minus 4. Now, as I do the math, in the top, 0 squared minus 7 times 0 plus 10 just becomes 10. And in the denominator, 0 squared minus 4 becomes minus 4. Again, pay attention to the sign. You have positive 10 over minus 4, which I can reduce to negative 5 halves. They're both evenly divisible by 2. Or you could write that as negative 2.5. Negative 5 halves and negative 2.5 is the same thing. So in terms of the limit, as you put in input values that are really close to 0, your output gets really close to negative 2.5. And again, the output is the height on the graph if you draw the graph. Now, part B, take the limit of x squared minus 7x plus 10 over x squared minus 4 as x approaches 1. Now again, I want to ask myself, can I put in a 1 as an input value and get an answer that's defined? And the answer is I can. If I put in a 1 for x, I do not zero out the denominator. I do get some type of an answer. So that's going to be my quickest, easiest way of finding the limit. So in the numerator, I'm going to put in a 1 for x. So the x squared becomes 1 squared. Minus 7x is really 7 times x, so it becomes 7 times 1. And there's a plus 10 at the end. Then in the denominator, x squared minus 4 becomes 1 squared minus 4. And now I'll do the math. On top, 1 squared is 1. 7 times 1 is 7. I have a plus 10 on the end. In the denominator, 1 squared is 1, so I have 1 minus 4. So on top, the 1 and the 10 are both positive. I'm going to have a positive 11, and I'm going to subtract 7. Positive 11 minus 7 is 4. In the denominator, 1 minus 4 is negative 3. Again, pay attention to the signs. So negative 4/3, or you can write negative 1 1/3. Those values are equivalent. And that is the value of the limit. So as you put in input values that are really close to 1 for this function, the output gets really close to negative 1 1/3. And finally, part C, find the limit of the same function, x squared minus 7x plus 10 over x squared minus 4, as your input approaches positive 2. So I'm going to take the same approach as I did in parts A and B. I'm going to just try and put in the 2 first and see what happens. And what happens is the function is not defined at 2. The bottom zeroes out. So in the denominator of the function, I have x squared minus 4, and if x is 2, 2 squared minus 4 is 4 minus 4, which is 0. So I can't just pop in a 2 and see what happens. So I have to do some factoring, cancel something. So let me write, I'm going to have limit as x approaches 2. And now the function that I want to take the limit of has an x squared minus 4 in the denominator. So I recognize how to factor that before I see what's being factored in the numerator. So I'm going to factor the denominator first. This is called the difference of squares. So I'm going to set up my parentheses. I'm going to go x, x. So they both have a square root, really. So the square root of 4 is 2. So I'm going to have a plus 2 and a minus 2. So that will factor the bottom. And now as I put in a 2 for x, the factor with x plus 2 is fine. 2 plus 2 is 4, not a problem. It's the factor with the x minus 2 that's the problem. When I put in a 2 for x, 2 minus 2, that's what's zeroing my denominator. So as I factor the top, I'm going to hope for a factoring that will give me an x minus 2 as part of the x squared minus 7x plus 10. So let's see if that'll work. So the other factor will have an x. I'm making a 10, so I should have a 5. And if I look at the signs, if it's minus 5, it should work. So you can check it. If you FOIL the top, x minus 5 times x minus 2, and you do the FOIL first times first and outer last, it will FOIL out to give you back the x squared minus 7x plus 10 that's in the top of the function. But now when it's factored, I have it factored in such a way that there's an x minus 2 in the numerator and an x minus 2 in the denominator. So now what I can do is cancel those and just take the limit as x approaches 2 of x minus 5 over x plus 2. Now that I can put in a 2 for x. So the top of that x minus 5 becomes 2 minus 5. And the denominator, x plus 2, becomes 2 plus 2. So the numerator, 2 minus 5, becomes negative 3. Again, pay attention to the signs. And the denominator, 2 plus 2, is positive 4. So I have negative 3/4. So the function, the way it's written in the beginning, x squared minus 7x plus 10 over x squared minus 4, is not to find a 2. I can actually not use a 2 as an input. But I can use input values that are really close to 2, like 1.999 and 2.0001. And as I put in those input values that are super close to 2, the output I'm getting is getting really close to negative 3/4. And again, that output, what that really means is the height on the graph if I graph this function.